Hello, my name is Colin McKenzie, and today we will look at the four different focus sequences offered in the UCSD SE program and their broader meanings and applications. We will first look at the civil structures subdiscipline. Civil is concerned with the design, analysis, and construction of traditional structures such as buildings, bridges, dams, and so on for primarily civilian and military applications. Civil is a critical subdiscipline as it encompasses most structures you and I encounter on a day-to-day basis, and therefore aims to ensure that said structures can be reliably used in an efficient and safe manner for large portions of the population. A common problem a structural engineer with a civil focus could encounter is one in which a city is trying to extend a rail line through a densely populated area and would need to construct an elevated track. The structural engineer's task would therefore be based on the route provided by the transportation engineers and city planners to effectively design the necessary decks and supports that would allow for a track to be built upon for the train to travel through the dense area. This example illustrates a type of career path in the civil focus in which a structural engineer could work at a transportation agency like Caltrans or TSA who focuses on designing the structural aspects of transportation infrastructure. Other examples of careers could also include an SE for water infrastructure, like dams and oil rigs, as well as SEs for more common urban uses like high, medium, and low-rise buildings. The civil background could also extend into management positions like construction and project managers. Next, we have the aerospace subdiscipline. Aerospace is concerned with the design and analysis of specialized materials and components that make up aerospace structures. Aerospace is a valuable subdiscipline of structural engineering, as it allows for teams that are working on aerospace structures to bring in specialists that can exclusively work on the vital material and component sides of a project that traditional aerospace engineers and technicians may not have as much concentrated experience in. An example of common problems an aerospace structural engineer may experience could be working for an engineering contractor and being brought in to design the whole of a commercial airline. Provided the constraints around weight and other mechanical and aerospace components that allow the aircraft to take flight, the structural engineer can effectively design the whole of the craft by utilizing lightweight materials of the correct stiffness to allow the aircraft to take off. This example leads into one of the most common types of careers for an aerospace SE, who works at a private company working on designing whole structures as well as even components for landing and takeoff gear of aircrafts. However, aerospace SEs can also work at a variety of organizations, private and public like NASA, SpaceX, and their universities like UCSD serving other purposes like conducting research that pushes forward innovation in the industry. Then we have geotechnical. Geotechnical is fixated on the designs of foundations and the different compositions of soil. Geotechnical SEs aim to analyze the mechanics of soil on the ground and assess how the characteristics of both soil and structures interact with each other. Geotechnical SEs are some of the most vital assets in the design of structures, as terrain can vary drastically from location to location, therefore demanding experts who can assess the quality of the site and what precautions to be taken when designing and constructing. Additionally, humans may want to develop inaccessible locations, and so geotechs can be brought in to oversee solutions like tunnels, retaining walls, land reclamation, and levees. A geotech may often encounter problems like a city trying to construct a building adjacent to a hill that is prone to landslides. A geotech alongside a team of surveying engineers would go to the site and analyze the terrain and soil, and propose solutions like constructing retaining walls to hold back the hillside, as well as drive pylons into the ground to reach soil that is less prone to shifting. A geotechnical structural engineer can be employed at a large variety of organizations and in a series of different roles spanning foundation designs for developers. He can also oversee demolition for companies and various applications. The last focus sequence is structural health monitoring, which is dedicated to the collection and analysis of data pertaining to the functional state of a structure based on the health of its components. Structural health monitoring specialists are becoming increasingly necessary as infrastructure throughout the world, and most predominantly in the US, reach the end of their lifespans. These types of SE will enable a better understanding of exactly how long said infrastructure will last and what measures can be taken to repair or replace them for long-term use. A common example of a problem a health monitoring SE could encounter would be a report pertaining to a freeway overpass that is reaching the end of its lifespan. The health monitoring SE would therefore derive a way to measure the structural state of the overpass components, and from that, identify where the problems lie. From this, the engineer could approach another team of SEs about the conclusions and what steps the team can take to retrofit or replace the structure. A structural health monitoring engineer can take on a variety of roles in the workforce relating to inspection, as well as writing software programs to analyze structural data. Of these focus sequences, civil is my favorite, as it allows engineers to push the limits of structural design of not only how spaces are designed, but the functions of structures themselves.